All right, now we're to the point where we can actually solve quadratic equations by factoring. All right, we went over all the different techniques of factoring. Not all of them, but most of them. And now we can actually take that and apply it to solving quadratic equations. Right. There's four steps you need to do. One, very first step is you set the equation equal to 0. So some will be like that, some will not, and I will show you how to do that. Once you do that, the next step is you factor completely by either using the GCF, difference of squares, or the AC easy method, or a combination of those. And step 3, then you set the factors equal to 0, which I'll explain what factors mean when we get to there. And once we do that, then you solve each factor and get your answers. All right? So we're going to keep referring back to this. Okay, first equation. So x squared minus x minus 42 is equal to 0. So you notice the first step is already equal to 0. So we can go on to the second step. We want to factor completely. There's 1, 2, 3. 3 terms. That means it has to be GCF and or the AC method. Right? Because remember, GCF can be in combination with this method. Well, there's nothing common in all 3 terms, so therefore we don't have to worry about the GCF. Now we use the AC method. I can't even spell, folks. All right, so here we are. We want the factors of 42. So factors of 42 that if I subtract, it will give me 1. All right, so the factors of 42 are 1 and 42, 2 and what? 21. 3 and what? See, 3, 14. Then we got 4. Does 4 go into that? Nope. 5. Nope. 6. What is that? 6 and 7. All right. I think that's it. So we want to subtract. So if I subtract, I'll get 41. If I subtract these, I get 19. Here I will get 11. Here I will get 1. And that's what my goal is. I want 1. So those are the factors that I need. So now I can go ahead, put my 2 sets of parentheses. Remember, it'll be just x and x. Make one 6, make the other one 7. Now we go back here and look at the sign. We know it's subtraction. All right? Subtraction, by definition, means that one term has to be positive, one term has to be negative. All right? So, how do I know which one is positive, which one's negative? Is the 7 the negative or the 6? Well, you look here. It's a negative there. So that means the larger integer or the larger number has to be negative. So that means the 7 must be negative. That must be the positive. Remember, this is still equal to 0. So now we have factored completely. So the next one, we're going to set factors equal to 0. These parentheses are called your factors. All right? That's why we take quadratics and factor. When you factor, you get factors. So I'll take the first factor, which is x plus 6, set it equal to 0. Take the other factor, x minus 7, equal to 0. And then the last step is solve. Well, there's 2 equations, so now I got to solve twice. Subtract 6. There's one solution. Add 7. And there's the other one. So I have 2 solutions. Let's look at another method, or another example, excuse me. All right, it's already set equal to 0. All right. So the next step is we want to factor completely. So do I use GCF first? Let's see here. Is there anything common in these 2? No. All right, so there's no GCF. All right, now this is how many terms? 1, 2. So there's 2 terms, so it has to be difference of squares. Right? Is it the difference of squares? Well, that's 7 times 7. That's a times a. Difference, all right. 16 is 4 times 4. Yes, it is difference of squares. So set up my two parentheses. 7a goes on to 1. 7a goes on the other. 4 goes in one. 4 goes in the other. And make one positive, make one negative. Now, since I use difference of squares, I have to check to make sure I factor completely. So here, that's a sum. So this factor is completely, so that means I can set that equal to 0. This one is a difference, all right? That's a perfect square. That's 2 times 2. But 7 and a, or doesn't matter, each of them are definitely not perfect squares. So therefore, this is factored completely as well. So I can go ahead and set that equal to 0. Now I solve. So, all right, subtract 4 from both sides. So I get negative 4. Divide both sides by 7. A is equal to negative 4/7. I do not want decimals. Leave it just like that. The only time I want decimals if you're graphing. We're not graphing here. So I want fractions. Make sure they're simplified. Add 4. 7a is equal to 4. Divide both sides by 7. And therefore I get 4/7. So there are my two solutions. All right, last example. All right, first step, set the equation equal to 0. Well, this is equal to negative 40. So that means I got to take this 40 and bring it to the other side, or add 40 to both sides. So I get x squared minus 13x plus 40 is equal to 0. All right, now, no GCF. There's 1, 2, 3 terms. That means that has to be the AC method. All right, so the AC method states factors of 40 that if I add will give me 13. So let's list the factors. We got 1 and 40, 2 and 20, 3, nope, 4 and 10, let's see here, 5, all right, 5 and what, 8, 6, no, 7, nope, that's it. Now we are adding, we're adding, so that gives me 41, nope, this gives me 22, nope, 14, nope, 8 and 5 is 13, so that's the one I want. I don't know why I crossed it out. 5 and 8, so here we go. We can go ahead and set up my two factors. So we have x and x, then make one a 5, make one an 8. Now this is addition, right here. This says addition, adding. So that means both of these signs have to be the same. Okay? But if the reason why they have to be the same, in order to add integers, integers have to have the same sign in order to add them. So I'm adding them. It's a negative though here, so that means both of these have to be negative. Now I can set these equal to 0, set each factor equal to 0. So x is equal to 5 and x is equal to 8. And there you go.